Okay, so the plan for today is quadratics. But before we do that, any questions in logarithms? Did you guys go through the video and did you finish up the backlog of homeworks from this past week and earlier weeks as well? Ahan, let me start with you. Have you done that?
So like not fully. So I went through like the video like once, but like I didn't fully like understand everything. So I plan to go through it again and then I'll like do everything because I have like quite a bit of free time now.
Yeah, please do that and don't let things accumulate. Otherwise, it gets harder and harder. So try to catch up. And thankfully, all the videos are there during the next few weeks. This is the last class before we break, right? So make sure you're solid on all of the topics we've discussed so far and catch up on all the homeworks, right? Go through them again. All the end of chapter on all the topics that we did so far, right? What all did we did? Exponentials, logs, arithmetic progression, geometric progression. Yeah, all that stuff. Okay, all right. So a plan for today is quadratics. Did we do any quadratic earlier? No, right? Maybe in the mock class, maybe I did, I'm not sure. No, right? Okay.
So we haven't
done that, right? Okay, share screen. Okay, so there are two things, right? Class is being recorded, right? I always get scared if it's not the case. Yeah, it's recording. Okay, so before we start quadratics, it's very important to know the difference between a function and an equation. Okay, so this is true for not just quadratic, it's true for anything really, right? Even for linear, it's true. Okay, so it's important to understand the difference. A function is like an expression. For example, if I have x squared minus 3x plus 2. Okay, so you have an expression. So this is an expression. So once you say, rather than me have to write all this entire big thing every single time, if I call it a small name called y, then it becomes a function. So this is a function. So a function is very, in layman's words, a relation between two variables, y and x. X is the independent variable. Y is the dependent variable in this case. Of course, you can rearrange, write x in terms of y and make the other one independent and this one dependent. But the way it is written right now, y is the independent one. Whatever you on the left-hand side, that's the y is the dependent one. Whatever you write on the left-hand side, and the independent one is on the right, x squared minus 3x plus 2. Okay. Now, what can you do with a function? You can plot a function. Okay, you can plot a function. Okay, so in general, a function might be like a linear line like this, or going down, or it could be a parabola. In this case, it's a parabola, right? It's a quadratic, therefore it will be a parabola, or it could be something like this, right? All of these are plottable. See, these are, and then you can ask a question. So let's say this is the x and y axis here. Okay, so back to the parabola here, you could ask the question, when is the y value 1? Let's say this vertical line is 1. So let's say this vertical line, what horizontal line, sorry. Let's say this horizontal line here. You guys are seeing my screen or not?
Yeah.
Yes.
You are right. Okay, cool. I got scared for a second. Okay, so let's say this horizontal line is y equal to 1. So you could ask the question, when is this function taking the value 1? But it need not be 1. It could be any other question could be, when does it take the value 0.5? When does it take the value 0? That's also a special question. And the answer to that is at these 2 points of x, right? Maybe I should have drawn the parabola a little deeper. Okay, so let me take a second shot at it. So let's say the parabola is something like this. And let's say the x and y axis are here. Okay, and then I ask the question, when is this function taking the value 0? So at these values of x, it's taking the value 0. These are special values on the function. Likewise, you could ask the question, when does it reach a minimum? So at this value, it reaches a minimum. And therefore, this point becomes a special point called the vertex. So you can do all of these with function. You can plot and ask a lot of questions. When does the function take a particular value? Or rather, when does the y value equal to certain numerical value, right? That's all function. And you can also factorize a function. So for example, this expression here, so this expression here is x minus 2 times x minus 1, as you can see easily, right? X minus 2 times x minus 1. So it's factorizable. So you can factorize a function and plot it. These are the main things. Whereas if you have an equation, okay, you cannot plot it. You cannot plot. Because what does it mean by saying what do you mean by saying an equation? You are asking x square minus 3x plus 2 equal to 0 by putting it equal to a numerical value. The right hand side need not be 0. The right hand side could be 10 also, right? It could be 100.7. It could be anything really, but you're setting it to be a numerical value. And generally it's convenient to put it 0, or rather, even if it's non-zero, move everything to the left hand side and make the right hand side 0. That's what an equation is. And then you ask the question, you ask what value of x satisfies this equation, right? And therefore, there's no notion of y at all here. There's only x. And therefore, on the number line, so there's only x-axis here. And then I can specifically say when x is, I don't know, I'm just making up some number here, may not be, okay, fine. In this case, x equal to 1 and x equal to 2, right? When x equal to 1 or when x equal to 2, x square minus 3x plus 2 is equal to 0. When x is anything else, it is not 0. So you're answering that question, right? So what are you doing? You're essentially solving an equation. You're solving, and then the answers that you're calling out are the solutions or the roots, right? Solutions or roots. Now, this fundamentally difference is very important between function and equation. Sometimes they are used in a confusing way. Even textbooks sometimes say solve. They'll give y equal to x square minus 3x plus 2, and they say solve. It's incorrect. You cannot solve a function. You can only solve an equation, right? But they are very, very related. The fact that you can factorize x square minus 3x plus 2 as x minus 1 times x minus 2 is very much useful, even though we learned that as part of function factorizing. This is useful. Why is it useful? Because if you have product, what is factorizing really? What does factorization mean? Factorizing means breaking a big expression into smaller expressions which are multiplicative. That's very important. Multiplicative. For example, suppose I have x square plus 10x plus 3. If I say it's x into x plus 10 plus 3, that is not factorization at all, right? Ultimately, at the highest level, it must be a multiplication. At the highest level, it's not a multiplication. You are doing x times x plus 10, and then you have 3, and then finally you're adding it. So the final operation that you're doing is addition. It's not multiplication. So factorization is breaking an expression into smaller expressions which multiply. The word multiplication is very clear, very important, right? So if you're able to factorize x square minus 3x plus 2 as the product of x minus 1 and x minus 2, why does it help? It helps in solving this equation. How does it help? When you have product of several terms equal to 0, what does it mean really? So for example, if I have product of m times a times p times w equal to 0, then I can say this product is 0 when either m is 0, or when a is 0, or when p is 0, or when w is 0. Some of them, it might simultaneously also be 0. But we can clearly say that this product is 0 when one of them is 0. Right? Exact same logic will use. If you're able to factorize, we can say x square minus 3x plus 2 is 0 when x minus 1 is 0 or x minus 2 is 0. Therefore, you're solved by saying, which means either x equal to 1 or x equal to 2, which is precisely what you want, right? Ultimately, you're looking for solutions or roots, which are values of x that will make this particular equation valid. X square minus 3x plus 2 equal to 0 becomes a true statement when x equal to 1 or x equal to 2. Again, all of this is known stuff only. I'm just emphasizing some formal usage. That's all. Okay, all of this is clear so far. Ahana, you're good. Avya, Ahan,
Yeah.
Subair. Okay, cool. Now come to quadratics, right? So we have a quadratic expression. The very first thing that you would want to do is factorization. So ultimately, factorization is important because if you set it equal to 0, it will help you solve it. But first, let's learn factorization. Suppose I have 2x square, what is it, minus 7x plus 6, let's say, right? Suppose this is the expression. How do you factorize? You basically say, find two numbers that add to minus 7 and multiply to the product of 2 and 6, which is 12. This is known stuff. That's how you factorize from like 8th grade. So this is important, right? 2 times 6. People forget the x square coefficient sometimes. So it's easy to guess that these two numbers are minus 4 and minus 3, right? You can see that the sum is negative, which means at least one of them is negative. And then you can see the product is positive, which means both numbers are negative. And then it becomes easy to guess minus 4 and minus 3. And then you will split like this, minus 4x, minus 3x, plus 6. And then I'll just go through the paces just to get us started why we are doing this. Right, minus 3 times x minus 2. And then we'll say this has been broken into 2x minus 3 times x minus 2. Now this is factorization. Why? Because you've broken it down into smaller units which are multiplying. That is key. Now, why does it help? It helps in solving the equation 2x square minus 7x plus 6 equal to 0. This is an equation. So how do you solve? By using the factorization that we just did, we can say 2x minus 3 times x minus 2 equal to 0. And therefore, we'll say x equal to 3 by 2 or x equal to 2. And then we have solved it, therefore. Okay, now the problem is not everything is factorizable. Not everything is factorizable. So for example, instead of 2x square minus 7x plus 6 equal to 0, suppose I just make a small tweak, 2x square minus 7x plus 5 equal to 0. Maybe this is also factorizable. Two numbers multiplying to 10 and adding to minus 7, that's minus 5 and minus 2, right? So maybe I'll give a better example, plus 4. Okay, so if I have 2x square minus 7x plus 4, that is not factorizable. I cannot find two numbers that multiply to 8 and sum to minus 7. Okay, now therefore, how would I solve 2x square minus 7x plus 4 equal to 0 by factorization? I cannot. Therefore, I'll have to discover another way of solving this quadratic equation. Quadratic means x power is 2. Just to be clear, right? X power 1 is linear. The maximum power of x, if it's 2, then it's quadratic. The maximum power of x, if it's 3, it's cubic, and so on. Right? All of these fall under polynomials. So polynomials. So polynomial cannot have anything other than an integer power of x. So for example, if I have x cubed plus sine x minus 13, it's not a cubic because we have a mixture of trigonometric thing as well. So it's not a polynomial. Similarly, if I have x cubed plus 2 times root x plus 12, it's not a cubic because I have root x, which is not an integer power of x. So all the terms must be an integer power of x. And the lowest integer is x power 0, which means you can have a constant term, but you cannot have 1 over x. So x plus 2 by x is also not a polynomial because the power of x here is minus 1. Okay, so anyway, those are all simple definitions. Right now, we are among the polynomials, we are doing the highest power of x being 2, which is x square. And therefore, it's quadratic. And you need not have all the terms. For example, even the expression 2x cubed plus 7 is a cubic. Even though there's no x square term, there's no x term, but the maximum power is what matters. Okay, now back to 2x square minus 7x plus 4 equal to 0. So we'll do both simultaneously, right? We'll have to factorize the expression 2x square minus 7x plus 4. We'll have to solve the equation 2x square minus 7x plus 4 equal to 0. So once you factorize, that will come in handy. So how do you factorize? So suppose I'll say y equal to so and so. So I can take the first step in factorizing is so we might not be able to factorize it exactly, but all I'm saying is you can reduce it a little bit. The very first step is making the power of the coefficient of x square, namely the highest one in this case, 1. How do I do that? I'll make it as 2 times and then put everything else within brackets. So it's 7 by 2x plus 2. Okay, so what we are learning here is completing the squares, a technique called completing the squares. You might have heard the word completing the squares. I'm not sure. Some of you might have heard. Completing the squares is what we are doing here. Okay, so what square are we completing here? So we took the 2 outside, so far very clear. So this expression, x square minus 7 by 2x plus 2, this is somewhat like p square minus 2pq plus q square. It smells like that. So let me draw an association between these two. So x looks like p, which is fine. X square is p square, minus 2 times p, which is x, times. Now let's pause for a second and see what should my q be such that it matches with 7 by 2. And we can easily discover that the q I'm seeking is 7 by 4. So that the 4 and the 2 can knock off to give 7 by 2x. All clear so far? Ahan, you're with me? Okay, so we have p square minus 2pq. So plus q square is missing. Okay, so let me add plus 7 by 4 whole square. Okay, and then I'll subtract minus 7 by 4 whole square because no one is going to give it to me for free. And then the remaining 2 that I have is as it is. So the expression here is 2 times this. Now this is the set of 3 terms, which looks like p square minus 2pq plus q square, right? This looks like this, right? And therefore, I can just say this is 2 times x minus 7 by 4 whole square, right? And then this is just numerical, right? Whatever that is, right? So in this case, it's 2, which is 4, 2, sorry, 2, which is 2 minus 49 by 16, right? This is 2 minus 49 by 16. How much is that? Minus 17 by 16, I guess. 32 minus, which is minus 17 by 16. Minus 17 by 16. Okay, so we have still not factorized, but we have simplified a little bit, and this is enough to be able to solve it. So not always we need to factorize to be able to solve. So we have, by completing the squares, we have reduced it to a form which will help me in solving it. Solving what? An equation if you set it equal to 0. How will it help? Now, if I come to the right here and just follow the exact same steps, right? So far I've not done anything. The only difference is the right-hand side was 0 in the case of an equation. The right-hand side was nothing, right? In the case of an expression, it was just a free floating expression. So I'll just use the same simplification and say 2 times x minus 7 by 4 whole square minus 17 by 16 equal to 0. Okay, so now while solving this, 2 is a separate multiplicative unit. This entire thing is a separate multiplicative unit. So we can say the solution for this is either when 2 equal to 0, which we know is not going to happen, which is why the 2 does not even matter, or when this guy is equal to 0. And when is this guy equal to 0? When x minus 7 by 4 whole square equal to 17 by 16. Which means what? X minus 7 by 4 is plus or minus square root of 17 by 16, which is 17 here upon 4. Which means x is 7 plus or minus root 17 whole upon 4. So we have solved this using completing the square. Is this clear? You have done quadratics to some extent, right? As part of 10th grade, you have done quadratics, right? You have solved for this.
Yes.
Right? Right. Now, if you recall the quadratic formula, let's blindly apply the formula. We'll derive it in just a second. 2x squared minus 7x plus 4, right? So suppose I didn't want to do all this completing the square. If I just want to apply the quadratic formula, so what will it be? It'll be, let me just recap the formula. It's the roots, right? The roots are, or which means x equal to, right? X equal to minus b plus or minus root of b square minus 4ac whole upon 2a. You guys recall this, right? Yeah, so in this case, it's minus b is plus 7, minus of minus 7, plus or minus root of b square, which is 49, minus 4ac, 4 into 2 into 4, which is your 32. 49 minus 32 is indeed 17, whole upon 2a, 2 times 2, which is 4. which is exactly what you get, 7 plus or minus root 17 by 4. So the quadratic formula that you have studied is a black box which does this completing the square behind the scenes for you and gives a capsule saying you don't have to go through all of these difficult steps every single time. I've done it for you. Just blindly use it, which is fine. It's blindly using it is fine. Sorry, using it is fine, but blindly using it is not good. You should know how this capsule is derived, which is what we just did. Right? We did with a numerical. Now we'll do the same thing with the most general ax square plus bx plus c equal to 0 and derive the formula for the roots of a quadratic equation. I'll pause here for a second. All of this is good. Any questions? Sumer, you're okay? Ahana?
No, so it's perfectly fine.
All of you fine? Ahan, you're okay? Yeah. Okay, cool. So exactly same thing. Instead of numericals, we are going to derive the roots of a quadratic equation. And this is very important because even though no one will ask you explicitly derive the equation, derive the roots of an equation, understanding this will really give you a good hold of quadratics. So let's do that. We'll do it slightly quickly only because it's important to grasp, but no one will ask you, right? So ax square plus bx plus c equal to 0. Okay. Now, the first step, what did I say? We'll make the x square coefficient 1. So I'll just take a outside. So it's x square plus b by a x plus c by a equal to 0. Okay. Now, what is the next step that we did? We wanted to convert this guy like a p square plus 2pq plus q. In this case, it's p plus q whole square. Earlier, it was p minus q whole square. Same thing, right? So I want to make an association such that this looks like, okay, p square plus 2pq plus q square. So p square ke jagah mein we have x square plus 2 times p, which is x. I'm thinking in my mind p, but it's x. And what should my q be? P upon 2a. So that it knocks off, the 2 knocks off to give b by a. So I've discovered my q. So this step is discovering what the q is. And then that will help you in completing the square, which is by adding the q square term, which is b by 2a the whole square. Okay, but no one is giving you b by 2a whole square for free. So I'll compensate it by subtracting it. And then the c by a just comes along very simply. Okay, now by doing this, we say this collection of these 3 terms is the square that I completed, right? So which is x plus b by 2a the whole square. Okay, and then what do we have here? So here, if I do it separately on the side, I have c by a minus b square by 4a square. So I can take 4a square common outside, as a not common outside, a common denominator. Therefore, it becomes 4ac minus b square. You can already see that you have expressions which are similar to what you have seen. B square minus 4ac, either 4ac minus b square, but plus minus chalega. Okay, so plus we have 4ac minus b square whole upon 4a square. Okay, equal to 0. Now, even though it's not factorized, this is enough for us to help solve this, right? Namely, solving means what? Finding the specific values of x when this will be true. A is clearly not 0, because if a is 0, then this is no longer a quadratic, right? If a itself is 0, then it's no longer quadratic. So we can strike off a here. Strike meaning what? We can divide both sides by a. The mathematics does not have a striking operation. We are dividing both sides by a and saying a gets cancelled. Here on the right hand side, 0 by a is 0. Okay, so which means my x plus b by 2a the whole square is, if I move the 4ac minus b square to this side, it becomes b square minus 4ac whole upon 4a square. So you can start smelling the answer is almost there, right? So which means x plus b by 2a is plus or minus the square root of the stuff on the right hand side, which is what? Square root of b square minus 4ac whole upon square root of 4a square, which is 2a. And therefore, now I can move the b by 2a to the right hand side and then keep the common denominator as 2a and complete it by saying it's minus b plus or minus root of b square minus 4ac whole upon 2a. Right, and these are the roots of the quadratic which you have seen multiple times in the past. Okay. Right. Now, Okay, so these are the roots, and you can see the roots are symmetric around minus b by 2a. So it's minus b by 2a plus something and minus b by 2a minus something. So you can just say minus b by 2a plus or minus something. What is that something? Plus or minus. In fact, I'll just call root of b square minus 4ac is a long expression that keeps coming over and over again, which is why people call it a simple name d. D for discriminant, right? Square root of d whole upon 2a. I mean, I can keep the 2a together in the bottom, but I want to illustrate that the two roots are symmetric around minus b by 2a. So minus b by 2a is a central point around which the roots are equally spaced. Okay, so this minus b by 2a has an importance. What is the importance? Now I'll be going back and forth between equation and expression. If you look at this expression itself, right? So if I started off by saying y equal to, so nothing changed. Before I cancelled off the a, this looked like this. Okay, and then this was, I'll write it as minus d by 4a square, because now I know that my d is nothing but b square minus 4ac. D is b square minus 4ac. So everywhere, instead of writing b square minus 4ac, b square minus 4ac, I'll replace it with d. Now this is the expression, right? Before we solved it. The next step after this, when solving, we just did the a does not matter. But if you write it as a function, the a of course matters. I cannot cancel off the a now, because y equal to a times something. A is like a scaling factor. When you're plotting x and y, the a does matter. When you're solving by setting equal to 0, the a does not matter, because you divide by a and it vanishes. Okay, of course, the a is appearing inside the bracket. That's a different thing. But the a that's outside, I'm talking about. While solving does not matter. While factorizing and deriving a value for y and plotting it, it definitely does matter. Now, if you analyze this expression, right? Sorry, I made a small mistake. B square, square root of d. 4a, right? Minus d by 4a. No. There's no square root here. Sorry, the square root was after that, right? I thought I missed the square root. No, I did not. I was okay initially itself. B square minus 4ac is d, and this is. Okay. So now, if you look at this expression, x plus b by 2a whole square, right? And the minus d by 4a square. X plus b by 2a the whole square, the bare minimum it will be 0, right? Because it's a non-negative quantity. It's not a perfect square, it's a square. Therefore, the bare minimum that x plus b by 2a the whole square will be is 0. And that bare minimum happens when x equal to minus b by 2a. So when x equal to minus b by 2a, you expect this function to have a turning point. Because if it's more than minus b by 2a or less than minus b by 2a, the expression that I've underlined will be a positive value. Therefore, very likely it's going to reach a minimum value. I'm saying very likely because if a were negative, the tables are completely turned around. It becomes a maximum value. So for now, just for understanding, let's keep a greater than 0, right? If a is greater than 0, right, and let's assume that, yeah, we don't have to assume anything else. As long as a is greater than 0, then the minimum value of this expression for y is when x equal to minus b by 2a. Agreed? And what is that minimum value? When you say what is that minimum value, I mean what is the value for y? By putting x equal to minus b by 2a, by construction, this becomes 0, right? Minus b by 2a plus b by 2a, the whole square is 0. So all I'm left with is a times minus d by 4a square, right? Which is minus d by 4a. So it's minus d by 4a. Okay, so this combination of minus b by 2a and minus d by 4a determine the coordinates of the vertex. Right? The coordinates of the vertex, when you have a parabola like this, this is the vertex, right? The coordinates of the vertex are minus b by 2a, comma, minus d by 4a. Okay, and we saw that the roots are symmetric around. So let's say it'll be like this, right? Just pretend this is, I'm not able to draw a straight line, but assume this is the vertex. Okay, so the y-axis and x-axis are here. The two roots are symmetric around minus b by 2a. So this is minus b by 2a minus root d by 2a, right? The two roots, right? And this is minus b by 2a plus root d by 2a. So it's symmetric about minus b by 2a, right? The coordinates of this, obviously the y coordinate is 0. I don't have to put that, right? Okay, fine, I'll put it. Okay, so the key point is, oh, this vertical line is bothering me. Why is it not vertical? Okay. I don't know. So I think this mouse is something. It's sensitive around this point. Okay, just pretend it's vertical. It looks vertical only. Okay. All right. So this vertical line is the axis of symmetry. So this vertical line is the axis of symmetry, right? The quadratic expression or the function is symmetric around that axis on the left and right hand side. So what is that vertical line? Any vertical line, the equation of any vertical line equal to x equal to something, right? So x equal to minus b by 2a. So in that vertical line, the bottommost point in that vertical line, namely the vertex, has a y coordinate of minus d by 4a, minus d by 4a. We just saw here, minus d by 4a. Okay, so
what if a is negative?
If a is negative, entire thing becomes ulta, right? So the parabola will look like this. So if a is negative, I'll just draw a picture here. So a is negative, then the parabola will look like this. And right, so this is the vertex. This will be the axis of symmetry. And let's say this is the x-axis. The two roots will be this and this. It'll still be true that this is minus b by 2a and minus d by 4a. And the two roots will be, as we just discussed, minus b by 2a plus something and minus b by 2a minus something, comma 0, comma 0. Okay, I'll just call the two roots are as alpha and beta, because those are the normal expressions that are used for the roots themselves, right? So alpha and beta are minus b plus or minus root d by 2a. Is this clear? Yeah, so something is bothering you still, or you're okay? You're okay, right?
Yes.
Okay, now I can write this expression. Okay, so this expression, I can write it as y equal to a times x minus h whole square plus k. I'll just explain this in just a second, right? So this is called the vertex form of writing this quadratic expression. Why is it called the vertex form? It's called the vertex form because I can directly read off my x and y coordinates of the vertex from this form. So namely, when x equal to h, that's when the turning point is. No matter if a is positive or negative, the only difference will be it's upward going or downward going. With a being positive, this will be the bare minimum point it will take. And what will the value for the function be when x equal to h? A times 0 square plus k, which is k. So if I write it in this form, I can directly read off the coordinates of the vertex, which is why it's called the vertex form of the quadratic expression. Is it clear? Okay, and you can clearly see, right? You can clearly see, I'll just, if I have to write, note that I've taken k outside here. So it's a times x minus b by 2a, the whole square. I'm writing so that it looks like x minus h whole square. H is minus b by 2a. And then if I multiply out the a with the 4a square, it will cancel 1a. So minus d by 4a. I'm getting the d by 4a square outside the bracket. So that I can see that when x equal to minus b by 2a, that's when this is the minimum. And the value for that y coordinate is minus d by 4a. All of you okay on this?
Yeah.
Okay. Ahan, you're okay?
Yes, sir.
Okay, cool. So to summarize, there are three forms of a quadratic function or expression: ax square plus bx plus c, which is the normal form that we start off with. Okay, and then the vertex form, okay, which is a times x minus h whole square plus k. Okay, so this is the vertex form. And then the coordinates of the vertex are minus b by 2a and minus d by 4a. And the third form is a times x minus alpha times x minus beta. Right? This is the factorized form. Right? Factorized form, which will help us solve for alpha and beta, which are the roots. So alpha is minus b plus root d by 2a, and beta is minus b minus root d by 2a. So this helps in solving. Right? All of these forms has a certain merit. For example, ax plus bx plus c, you can ask what is the merit. I can quickly infer what the y-intercept is. The y-intercept is c directly, 0, c. Okay. Now, the next important thing is sum of roots and product of roots. So sum of roots. Okay, I'll pause here first. All good so far, right? All of these three different variants are okay, right? So sum and product of roots.
Yes.
Okay, sum of roots. So in your roots, when you take the roots alpha and beta, and when you sum, what do you get? Alpha plus beta, the root d by 2a gets cancelled if I add these two. So I'm just left with minus b by 2a. The minus b by 2a plus minus b by 2a, which becomes minus b by a, which is similar to what we just saw. We saw the average of the two roots, the Bichka point, which is the x coordinate of the vertex, was minus b by 2a. Now it's twice the average is the sum, minus b by a is the sum of the roots. And why this is important, you will just see in a second, right? And what is alpha times beta? Alpha times beta, if I literally multiply it out, so minus b plus root d and minus b minus root d by 2a and then by 2a. When I multiply, in the bottom I get 4a square. In the top, it looks like p plus q times p minus q. So it's minus b whole square, p square minus q square, right? So it's b square minus t, and d itself is b square minus 4ac. Okay, so b square gets cancelled, which is 4ac upon 4a square. So 4a gets cancelled, leaving c by a. So the product of roots is c by a. Okay. Now, why is this? This is immensely useful. Okay. So the Cartesian form that we just saw at the beginning, so I can write it as a times, so y equal to a times x square plus b by a times x plus c by a, right? So in other words, it's nothing but a times x square minus sum of roots times x plus product of roots. So this is sum of roots, I'll call it S, and this is product of roots, which is P. Which is why it's closely related to factorizing. When you're factorizing, what are you doing? You're finding two numbers which add up to this middle guy. Forget the negative sign, you'll understand why that is in a bit. But roughly speaking, we'll find two numbers which add up to that middle guy and multiply it out to the last guy, right? P. Why are we doing it? This is the reason for it, right? The sum of the two roots. If you do that, you get the factorization and then you get the roots from there, right? So this is what is happening. X square minus sum of roots into x plus product of roots. Okay. Now, so if you're solving a quadratic equation, So let's say have ax square plus bx plus c equal to 0. Okay, so this is the quadratic equation. Actually, so before I go there, so given a quadratic equation, you know how to solve. So given a quadratic equation, you know how to solve. Either you can factorize and solve, okay, or you can complete the squares. Complete the squares, the technique that we just saw, or use a quadratic formula, right? The quadratic formula is a canned version of completing the square. It's not dropped from sky. It's completing the square, done and dusted for you already and given as a capsule, right? That's a quadratic formula. Using one of these three methods, you'll be able to solve the quadratic equation. But what is the reverse? For example, can you tell me what is the quadratic equation whose roots are, I'll give you the roots. The roots are 5 and 7. Avya, can you tell me the quadratic equation whose roots are 5 and 7?
So we need to find in the form of like, so first we can write as a into x minus 5 into x minus 7.
Yeah.
No, yes, sir, like that.
Like this?
Yes, sir.
Correct. That's right. Equal to 0. You're asking for an equation, right? Therefore, you put equal to 0,
Yes, sir, yeah,
which means the a does not even matter. So it's just x minus 5 into x minus 7 equal to 0 becomes the quadratic equation. Or you can just say x square minus 5x minus 7x, which is why it becomes 5 plus 7x plus 5 into 7 equal to 0. Right? So x square minus sum of roots into x plus product of roots equal to 0. So given the sum and the product, I can simply write the equation as x square minus sx plus p equal to 0. Okay, so what am I getting at? So if I know the roots alpha and beta, okay, so if I know alpha and beta, okay, I'll explain in just a second what I mean here. So the roots are alpha and beta. Okay. Okay, so given this is a quadratic equation, I'll be able to solve for the roots, alpha and beta, by one of these three methods that we just saw. By using one of these three methods, I can solve for the roots. Alpha is so-and-so and beta is so-and-so. And then what about the reverse process? If I know alpha and beta, can I generate the quadratic equation back? This is exactly what Avya told. If the roots are alpha and beta are numericals here, I can say the equation is sum a times x minus alpha times x minus beta equal to 0. And then the a does not matter because the right-hand side is 0. I might just say x minus alpha times x minus beta equal to 0. So this process is easy. X minus alpha times x minus beta equal to 0. So given the roots, you will be able to find the quadratic equation, right? And given the quadratic equation, by using one of these three techniques that we just saw, right? Either by factorizing. So I'll just say 1, 2, and 3 that we just saw, right? 1, 2, and 3. One of these three, I can find the roots. Now, the third pillar to this is the sum of roots and product of roots. Suppose I know S and P. Okay, the sum and product of roots. So for example, Ahan, can you tell me a quadratic equation whose sum of roots is 13 and product of roots is 15? Can you tell me such a quadratic equation?
Yes, I'm just thinking.
Yeah.
So I'm not sure. So
Sumer, you want to try this? Sum is given, product is given. What is the quadratic equation?
So I'm not sure.
Okay, Ahana?
X square minus 13x plus 15.
Equal to 0. Yes, we just saw, right? X square minus sx plus P equal to 0. Right? So it's just that. So if I know the sum and
Oh,
product.
so I thought you wanted us to find the roots.
Yeah, that's precisely my point. You don't need to find the roots if your goal is just to find the equation. Okay, which is why I intelligently gave numbers like 13 and 15. So suppose instead I had given sum is 13 and product is let's say 22. Then you would have easily guessed the roots are 11 and 2, and then said the equation is x minus 11 into x minus 2, because two numbers that multiply to 22 and add to 13 are 11 and 2, right? But because I gave 13 and 15, you could not guess what the two roots are. But you don't need to guess what the two roots are if your aim is only to come up with the equation. And the equation is very simple: x squared minus sum of roots into x plus product of roots equal to 0. Is this clear? Why this is useful will come in a bit. In some time you'll learn. But it is possible that if you know the sum and product, I can come up with the equation straight away. Okay, and then how do I traverse the reverse process from here to here? So if I know ax squared plus bx plus c equal to 0, then I know my sum is minus b by a, my product is c by a. We saw that also. Okay, and then if I know the roots as alpha and beta, can I find the sum of roots and product of roots? Yes, this is simple addition and multiplication. It's asking, can you do addition? Can you do multiplication? That's all. Right? Now, the reverse process is the only one which is not possible, which is what Sumer was trying to do in his mind. When I gave the sum and product as 13 and 15, he was trying to find out what two numbers could alpha and beta be, and he struggled. Had it been 13 and 22, he would have found them very easily as 11 and 2. So either you can guess. So this is sometimes guessable, like 11 and 2 was guessable if the sum and product worked out nicely. But if it's some weird number, it's an irrational number, you cannot guess. Therefore, you'll have to find the equation, namely x squared minus 13x plus 15, and then solve that using any one of these methods. So x squared minus 13x plus 15 equal to 0. Suppose I'll have to indeed solve for the roots, which is what Sumer thought my initial question was. Then I have to go to the equation and then solve it by using minus b plus or minus root of b square minus 4ac whole by 2a. Is this clear, guys? Right? This entire operation is clear. Okay, so whatever that is, 13 plus or minus, it'll be a weird number, right? 60, 109. Now, he could not have guessed that the two roots are 13 plus root 109 by 2 and 13 minus root 109 by 2. Because if he did, then he won't be sitting in this class. He'll be writing the International Math Olympiad. Right? Is this clear, Sumer?
Yes, sir.
Okay, cool. I think we have done enough theory. Let's dive into the questions from the end of the chapter. That's the best way to learn quadratics, right? Can you guys all open up your textbook? The Hayes and Harris book. In fact, quadratics is the first chapter in that. Let me know when you have it. It's page 47 in the textbook.
So could you just scroll up a little bit, like just a little bit?
Yeah. Just 1 second. I'm just copy pasting this first. Scroll up a little bit. Okay. Yeah.
That's enough. Thank you.
Okay. All right. If you open up the textbook, this is the question 1 in the exercise set 1A in page 47. Can we all try this? I'll give 2 minutes for you to try this fully. Okay, shall we discuss? Ahana, what are the x-intercepts of this quadratic function?
-2 and 1.
-2 and 1, because that is those are the values of x which will make it pass through the x-axis. X equal to -2 and x equal to 1. Okay. The intercepts are -2 and 1, like you rightly said. The values on the axis that it passes through are -2, 0 and 1, 0. Okay, state the equation of axis of symmetry. Ahan, or part B. What will the axis of symmetry be?
So
This is the y-axis, the x-axis. Okay, so let's say the roots are at -2 and +1, right? So it passes through this point and this point. Okay, what is it that we learned about the axis of symmetry, Ahan, in relation to the two intercepts or the roots?
so I think so.
That it was symmetric, right? The axis of symmetry was beach.
Yes.
Okay, so now can you tell me what will the axis of symmetry therefore be? So halfway between -2 and 1 would be average of -2 and 1 is how much? -2 plus 1 whole divided by 2, which is -0.5. So the axis of symmetry will be somewhere here like this. Right?
Yes.
And therefore, what is this axis of symmetry? Can you call out what the axis of symmetry? This vertical line has an equation of what? Ahan.
So like the coordinates or like
The equation of the vertical line, the vertical green line.
so
Any vertical line is x equal to something, right? So maybe I'll
yes,
help you, right? X equal to -half. X equal to minus b by 2a, exactly, yes. X equal to -b by 2a. If it was in the form ax square plus bx plus c, then it'll be -b by 2a. In this case, I'm just doing an average of -2 and 1. It's -half. Therefore, the vertical line, which is the axis of symmetry, is x equal to -half.
Yes.
Correct? Okay. Avya, y-intercept.
So 4.
4. How do you get that?
So you just plug in x is 0. So you just do 2 and
Exactly.
2. Yes.
Yeah, exactly. Plug in x equal to 0. You get the y-axis where it intersects. It's 4. So on the y-axis, it's intersecting at 1, 2, 3, 4. Okay, so here. Okay, and coordinates of the vertex. Sumer, coordinates of the vertex.
So I'm just using the minus d by 4a.
Yeah,
That's
correct.
fine, right? So I'm getting -2. So I'm getting my 34 by 16.
34 by 16. Yeah, either you can do that or directly substitute x equal to, what is the x value? -half, right? So it's -half plus 2. And then -half minus 1. Right? I'm putting x equal to -half in the function. So y equal to -2 times -2 plus half is 3 by 2. And -half plus 2 is 3 by 2, and -half minus 1 is -3 by 2. And you'll see this often. The factorized form, the two values will be exactly negatives of each other when you substitute. That's a good check you can do. Right? So it's what did you say? When you multiply, it becomes 9 by 2, right? What did you say? I forgot what you said. Ahana, what did you say? I'm sorry.
No, sorry. I just said I got 9 by 2.
9 by 2. But what is the answer that you called out, Sumer?
Wait, so sorry. I used minus d minus 4ac upon 4a. That's correct, right?
Minus b square minus 4ac upon 4a. Minus d by 4a. But
I wrote d. Yeah, sorry.
Okay. Okay.
Yeah, that's
okay.
fine.
Let's check that also, right? So for which we'll have to expand this out and write it as minus. We'll expand this and write it as ax squared plus bx plus c. When I do that, it's -2 times x plus 2 times x minus 1, which is x square plus 2x minus 1x. So becomes plus x minus 2. which means it's minus 2x square minus 2x plus 4. Now in this, if you apply minus of b square minus 4ac by 4a, you should get the exact same answer. Let's check, right? Let's first keep what b square minus 4ac is, since we'll often need it. So b square minus 4ac is, b square is minus 2 whole square, right? Minus 4ac is 4 into 4 into 2, which is 32, right? That's b square minus 4ac, which is 36, right? And therefore, the coordinates of the vertex are minus b by 2a, which we anyway got it as minus, or rather here, you can just do minus of minus 2 minus b by 2a, which is minus 4. Minus of minus 2, which is plus 2, upon minus 4, which becomes minus half, so it matches. And then the y coordinate is minus d, which is minus 36, by 4a. 4a was 4 times minus 2, which is minus 8. That also matches with 9 by 2. 36 by 8 is 9 by 2. And 9 by 2 is 4.5, which is, as expected, slightly above the value that you got as the y-intercept. Why? Because it's an
But
inverted.
isn't it minus d, so won't it just be 36?
D itself is 36. Therefore, minus d is minus 36.
Wait, sir, but isn't d 4 minus 32 and not 4 plus 32?
D is 4 plus 32, agreed.
So wait, so isn't it b square minus 4ac?
Correct. But the 4ac involved a negative, right? 4 times minus 2 times plus 4, right?
I did c square minus 4ac. Yeah, sorry, my bad.
Okay. Okay. So the coordinates of the vertex, we all agree, are minus half, comma 4.5, and 4.5 is slightly above 4. And that's also consistent with the points that we have got so far. What are the points we got so far? We got the two x-intercepts, we got the y-intercept, and we got the axis of symmetry, and a particular point of the axis of symmetry called the vertex. And we also saw that it's a downward going parabola because the coefficient of x square is negative, or rather a is negative. And connecting all of this, we can sketch the function, which is going to come. Sorry. So the function will come like this, right? So if I plot the function, it'll go like this. It'll reach a peak here, it'll come here. Okay. And so on. I mean, I'm not able to draw it too well here, but you guys can draw it and extend it like this. So this is an inverted parabola. Is this clear, guys? Completely, everyone?
Yes.
Yeah.
Okay, Ahan, you're good on this one now completely?
Yes.
All of these parts? Okay, cool. There is the, I had the textbook just now. Where did it go? Huh? Ah, there it is. Okay. Solve using exact answers. Okay, can we do question 4? Solve by completing the square. X square plus 7x minus 4 equal to 0. By completing the square, solve it. And then we'll verify it using the quadratic formula also. But I want you guys to get practice of completing the square. You already know the answer by doing minus b plus or minus, but keep that for verification. What am I? I'm sharing the. Okay. Ahana, can you help here? Completing the square.
Okay, so basically the coefficient of x is already 1, so we don't need to take out anything. So basically what we're going to do is x square plus 7 2 into 7 by 2 into x.
Yeah.
Plus 7 by 2 the whole square.
Yeah.
Minus 7 by 2 the whole square.
Yeah.
Minus 4 equal to 0.
Exactly.
Yeah. And now we're going to solve it. So we're going to take out x plus 7 by 2 the whole square.
Very good.
Yeah. Minus 7 by 2 the whole square, which is basically 49 by 4.
Yeah, we can move both
Yeah.
of these negative to that side. So it's plus 4 and plus 49 by 4. Yeah.
So it'll come out as 65 by 4, I think. I haven't done that part yet.
49 plus, you're right.
Yeah, 65 by 4. Then we're going to root that side. So x plus 7 by 2 equal to plus minus root 65 upon 2.
Exactly.
And then we'll plus 7 by 2 to that side. So we're going to get minus 7.
Yeah.
So minus
So
7.
put that minus 7 at front, in the front, so that it's always minus 7 and the plus minus does not apply to it. Wonderful.
Yeah, whole upon 2. Yeah.
Yeah. Perfect. Did all you guys do the same thing, more or less? Sumer, you got the same answer? Yeah. Ahan? Ahan, you had a doubt?
Yes, sir.
No.
You're okay, right? And then by verifying minus b plus or minus, let's check if we get the same answer. So can we all do that as well? So minus b, we'll do together, it's fine. Plus or minus root of b square, which is 49, minus 4ac. So minus 4 into 1 into minus 4. So it becomes plus effectively, whole upon 2a. So it's minus 7 plus or minus root 65 whole upon 2, which matches with the answer that she got earlier. Okay, except that we did by first principles. We didn't apply any formula. The completing the square is like by first principles, we derived it. Okay, cool. Well done. Okay, question 6. I'll assign the rest as homework, but I'll just try to do a sample of questions. Okay, so this is something I have to slightly, I haven't covered this yet. So the quadratic that we see, right? So let's say this is the quadratic and the x-axis is here and y-axis is here. Why does the quadratic have to necessarily cut the x-axis? What if the x-axis and y-axis are here and the quadratic goes above without cutting it, right? That happens when the b square minus 4ac, which you have within the root, right? What are the roots of the quadratic equation? Minus b plus or minus root of b square minus 4ac whole upon 2a. So this phenomenon happens when discriminant is less than 0. If discriminant is less than 0, then I cannot find root of a negative number, which means you won't have a real value where the graph will cut the x-axis, which is why if you plot it, it'll be like this. It won't cut, right, the x-axis at any point. As opposed to this phenomenon here on the left will be when discriminant is greater than 0. You have a valid square root, and therefore you have two different roots, right? Two different roots. Whereas if discriminant is exactly equal to 0, then we have minus b plus or minus root 0 by 2a, which means we only have minus b by 2a. Both the roots are minus b by 2a. The vertex is also minus b by 2a. So in such a case, the graph will just graze through the x-axis. So this will be both the roots as well as it will be the vertex, right? They are called coincident roots. Go ahead, Ahana.
No, so only one root, right?
Actually, technically, there are two roots, but people might say it's only one root. It's a repeated root. It's two roots, but coincident roots on that same point. A quadratic will always have two roots. Even in the case when discriminant is less than 0, it has two roots, except that in the real world, we are not able to see those roots. Later, when you study about complex numbers, you'll see the two roots are complex roots. So two roots always exist. Either they are two real roots, or it's one real root, but it's coincident. Therefore, there are two roots, but coincident at one point. So it feels like it's only one real root, as Ahana was also hinting, but it's actually two roots, but both coinciding at that point. And then if discriminant becomes less than 0, even that is gone. There's not even a single root in the real world, but in an imaginary world, also known as the complex world, hence the study of imaginary numbers or complex numbers, the two roots do exist. So we'll come to that in a later chapter, right? But for now, you can just differentiate very naively by saying two roots, one root or 0 roots. So one root is when the graph touches the x-axis, right? And that happens when discriminant is equal to 0. Is this clear, guys? Okay, so the part A for this is that sort of thing. Touches the x-axis at 4 means what? Both the roots are 4 and 4, and the vertex is also 4. Okay, give it a shot and then we'll discuss 6A. Abhiya, you want to try 6A? What is the equation of the quadratic? Whose function is this?
So I can try. So can I solve it first? Then
Yeah. I'll give you some time. Yeah.
okay, so I'm done.
Okay, go ahead, please. Abhiya.
So you can obviously write this as a into x minus 4 into x minus 4, which is also written as a into x minus 4 square.
Yeah.
So then you just plug in the x value is 2 and the y value is 12, and then you can find a.
Excellent. Yes. So basically, just to repeat what he said, he touches the x-axis. It touches the x-axis at 4. So it's a graph something like this, right? So the graph is this x-axis, let's say, right? So this is 4, 0. So the roots are both 4 and 4, which means if they're alpha and beta, it'll be like this, right? So he's saying both alpha and beta are 4 in this case. Therefore, the quadratic is a times x minus 4 times x minus 4. It's a repeated root, or x minus 4 whole square. And then now, how do I solve for a? How do I find? I don't want to use the word solve. Yeah, how do I find out what a is using some extra information that's given? What is that extra information? It passes through 2, 12. So when x is 2, y is 12. So 12 when x is 2. So this is minus 2 whole square, which is 4. Therefore, a is 12 upon 4, which is 3. Therefore, my quadratic just becomes 3 times x minus 4 whole square. Okay, but I cannot leave it in this form because he wants in this form, ax square plus bx plus c, right? So I'll expand it and write it, right? So basically 3 times x square minus 8x plus 16. And then I'll multiply by 3 also because he wants it literally in ax square plus bx plus c. So whatever form he wants, make sure you leave it in that form. So my a is 3, my b is minus 24, my c is 48. Does that make sense? Well done. Clear to everyone else? Sumer, you got the same answer? You're clear?
Yes.
Okay, 6b. Sumer, I'll give it to you, but all of you will try it.
Wait, so can you repeat what the form to write in a vertex was? Bx minus h1.
So in the vertex form, it is y equal to a times x minus h whole square plus k. I'll paste this question here.
And the thing is just h comma k, right?
The whole point of writing it in this form is I can read off the vertex as h comma k.
Alright.
And the h was minus b by 2a, and the k is minus d by 4a. Yeah, Sumer, you're done?
So I'm not fully done, but what I'll just tell you what I've done till now. I'll
Sure.
be able to do more as like if I speak and do it, I think.
Yeah, please.
So what I did was so we know h, we know k, and we know x, and we know y. So we can figure out a like that. Like
Well, we don't know x and y, but yeah, you're writing x and all. Okay.
yeah, like as in 1 and 11. So I just did a 1 minus 4 whole square plus 1.
Okay. Okay, so please repeat. So you said 1 equal to, is that what you said?
No,
1
11,
equal to
11 equals to.
passes through 1 comma this one you're using.
Yeah, so isn't this just 11 equals to?
Okay, you're right. 11 equal to
A
a
into
times
5 square. Which I mean, yeah,
1 minus 4
yeah,
whole square
plus 1.
plus k, which is 1. Yeah.
Yeah. So 11 is equal to 25a plus 1.
Yeah. Therefore,
So
a
is just 2 by 5. Yeah,
Correct.
it's 2 by 5. And now once you know a, you know minus b by 2a is equal to minus 4.
minus b by 2a, which is the coordinates of the vertex, is
Yeah, is equal to minus 4.
minus 4, the x coordinate of the vertex. Yeah.
Yeah, and you know what a is 2 by 5, so it's 4 by 5 minus b by 4 by 5 is equal to, yeah,
Okay, therefore b is
minus 4.
16 by 5 or something, right?
Yeah.
Okay, and then
Some isn't this minus 16 by 5?
no, the two minuses get
Oh yeah,
cancelled.
okay, okay, like that. And then you can put it in the minus d by 4a because now you know everything other than c.
Mhm.
And the form, one sec, what is the formula for that? Yeah, minus brackets b square minus 4ac upon 4a.
So 16 by 5 whole square,
Yeah,
right? Minus 4 into 2 by 5 into 1 whole upon 4 times 2 by 5, correct?
yeah.
And that equals,
So it's
sorry, this is not
256 by 25.
okay. So no, this big expression minus d by 4a equal to numerically what?
Oh, this is just equal to 1.
1, the y coordinate of the vertex, which is 1.
Yeah.
And then using this, you'll solve for your c, right?
Yeah.
Okay, c is hiding here. What you did is theoretically right, but it's a little like windy, right? You can do it much simpler. Yes, conceptually, you're absolutely right. So let's start off again. So I'll start off by saying y equal to, okay, I'll just do it in a different color, right? So my vertex form is y equal to a times x minus h whole square plus k. So y equal to a times x minus h. H is what? This is my h and this is my k. X minus minus 4, okay, plus k, which is plus 1. And then in the next step, put x equal to 1 and y equal to 11. That way it's clear. So you straight away started off in the second step. So it was not very obvious where that was coming from. I understood, but just to make sure that when you're writing, everyone else is clear. So hence you found so far so good, right? Till here it's fine. But after this, you don't need to struggle so much to find my B and C. Instead, I'll directly substitute my 2 by 5 in this. Sorry, where did it go now? Okay, so I'll just erase off the pink. So my equation is right there. So the equation is y equal to 2 by 5 times x plus 4 whole square plus 1. All I have to do is expand this. That's much easier, right? You don't have to find all of these big, right? And expanding this is very easy, right? So it's 2x squared by 5x, 2x squared by 5, and then 16x by 5. And then the C term is 2 by 5 times 16, whatever, 32 by 5 plus 1, which is 37 by 5. So it comes out straight away from there. Is this clear, Sumer? I just put my A in, but you're absolutely right. Your B indeed was 16 by 5, which you got by that method. C, we did not finish solving by your method, but if you did, you will still get the same answer. Okay. Okay. One other question I'm going to ask. So I will say on the same question in 6B, I will ask, the same graph, it passes through, let's say M, 11. Can you find M? Other than 1, it passes through some other point whose x coordinate is to be found out. Find M. Question is find M.
So do we know the other stuff? Like, do we know what the equation is or no?
Equation, Abhi, you have done, right? You've got this so far, all of this. We just did this problem,
After
right?
that. Yeah, okay. So after we figure this out?
Yes. Actually, that is actually the question I was going to ask you. You don't even need to figure out so much to answer this question M. Can you guys answer it without doing all of this? So answering M is immediate. Why is it immediate? Can you think?
So I didn't quite understand the question.
Okay.
Could you repeat?
Sorry, I was also not clear. So 6B, okay, the question is find in the form ax squared plus bx plus c, the quadratic whose vertex is -4, 11, -4, 1 passes through 1, 11. As an extension to that, I'm asking one more. This quadratic function passes through M, 11. Find M. Other than 1, right? It passes through 1, 11. But other than 1, there's also another M where it passes through M, 11. Is the question better now, Vahana?
Is it -9?
Minus?
9?
Correct. What did you do?
The vertex, so like the vertex will be a part of the axis of symmetry. So like -4 is
Exactly. Yeah. So what she did is, so this is an upward going parabola. So -4 is here, -4, 1. I don't care what this thing is, the y coordinate of the vertex is. And now, since it's symmetric, so what did we see? We saw that any y value will be symmetric, right? So it'll be on either side of this -4. So if we found out that one of them is to the right, which is 1, so this x gap is how much? From -4, it took +5 steps to reach 1. So you have to take -5 steps to reach on this side, which is -9. So it'll pass through -9, 11 as well. Does it make sense? Yeah. Okay.
Yeah.
Ahan, what is for 6B, what is the equation of the axis of symmetry? What is the equation of axis of symmetry?
So equation. So is it not like x equal to minus?
You're murmuring. You're right. I want you to confidently answer that. X equal to?
So -4.
Exactly. Yeah. The coordinates of the vertex, x coordinate is what will determine the axis of symmetry. Axis of symmetry is -4. X equal to -4 indeed. Okay. Sumer. What do you think about discriminant of this question for 6b? Yes, you have solved it as y equal to x squared plus bx plus c. You got this 2 by 5, 16 by 5 and all that. But even before you proceed till that step, would you be able to comment on discriminant being greater than 0 or less than 0 or equal to 0?
So what being greater than 0?
The discriminant, capital D, which is b square minus 4ac.
Wait, so
Think about it. Yeah. Not a very straightforward question. You have to think. All of you think, please. I'm asking this to Sumer, but it could be anyone.
so without knowing what A is,
Without knowing anything, without solving, yeah, correct. Without knowing A, yes. Without solving for A, B, or C, if you look at the question 6b, will you be able to immediately figure out if the discriminant is greater than 0 or less than 0 or equal to 0? In fact, I'll hide all of this clutter. I'll paste the question here straight away, right? Just by looking at this, you should be able to tell.
is it something to do with the root being positive? Like square root of D is positive.
When D itself is positive, I'm asking if D is positive or D is negative or D is 0.
So if D was negative, then won't there only be one solution?
If D is negative, there'll be no solutions. Both the solutions will be imaginary.
Yeah. So doesn't D have to be positive?
Why? Where does the question say it has at least one solution?
Oh.
Anyone? Ahana, you want to answer?
So I guess you could imagine the graph in your mind and looking at the different quadrants, because like it's passing through 1,11. Its vertex is like lies in the third quadrant, which is -4,1. I guess based on it's in the second quadrant. So based on that, maybe we could identify if it has.
Yeah, you're almost there. Can you elaborate a little bit more? So I will plot. So -4,1 is approximately here, right? This is the vertex. Okay,
Yeah.
and 1,11 is somewhere out here somewhere. Let's say 1,11. This is 1,11. Okay, now what are you saying after this?
Based on like this itself, like maybe we can figure out
How? That's my question.
because the vertex is above the axis of some like above the x-axis, right?
Yes.
So I think the D should
Therefore,
be
it
less
won't-
than 0.
Therefore, it won't touch the x-axis. Like that, we know that the parabola isn't touching the x-axis now, so we know that it. D
Exactly.
is
I
less
wanted you
than-
to complete that answer fully. So 1,11 is here. So the other symmetric point which I asked, right, will be somewhere here, right? And later you can figure out it's -9,11. But you can see that the graph, if it has to pass through these 3 points, is going to go something like this, right? Which means it's it's not even touching the x-axis at any point, which means discriminant is less than 0. Arya, what were you saying? Sorry, Avya, what were you saying?
So since since the
Same
vertex over the x-axis, it's not going to touch the x-axis only. So it has to be less than 0.
And then later, while simplifying, Sumer, you arrived at a point where you got A is 2 by 5, but that was later, right? And you said x plus 4 whole square plus 1. Something like this you got, right? If you remember, right? And here you can see that x plus 4 whole square, at the bare minimum, it can be 0. So this entire expression, the bare minimum will be 1. And that's the one here. The bare minimum value that this guy will take is -4, 1. Is the bare minimum value this guy will take is 1. And that happens when x equal to -4. So which means it won't go down to 0. Does it make sense? Sumer, you're okay?
Yes.
Okay, just one thing, Ahana, on what you said. just because the vertex is above the x-axis, don't immediately conclude there's no
We're
roots.
also looking at 1,11, right? But if you only look at
Correct. It's
yeah.
upward going. Correct. Right. If I'm just given the vertex, it can always go down like this from -4, right? Like the x-axis can be below this. So you need multiple information to conclude that, but you rightly did that. Cool. All right. Okay, let's do question 8. I will do it since you guys. Okay, I'll just give you guys 2 minutes to think about it. But you have not encountered this type of question before. Or have you? The roots are blah, blah, blah. Find an equation whose roots are 1 by alpha and 1 by beta. Have you done this kind of question before? You have? Avya, you were nodding which way I couldn't tell. Yes or no?
So I haven't, but like in me, so just look at this.
Okay, so this is a concept you guys have not learned, right? So let me just do it, right? So, and there'll be other questions where I can ask you. Okay, so if I blindly try to solve, so it'll become 2x square minus 3x minus 4 equal to 0. So if I solve for my alpha and beta, that'll be minus b plus or minus root of b square minus 4ac will become plus here, plus 4 times 2 whole upon 2a, which is this. So it'll become 3 plus or minus root 41 by 4. So as it is, it's looking very clunky, right? And then if I do 1 by alpha and 1 by beta, is even more pain. And then I'll have to find an equation whose roots are that. So it's going to take a long time. So that's not the approach to do. I'm just telling that that approach will be very long. You guys agree? So what is the better approach? Sum of roots, product of roots comes in handy here. So 2x square minus 3x minus 4 equal to 0. I'll start again. Okay. Alpha and beta are the roots. So the sum of the roots alpha plus beta is minus b by a, which is 3 by 2. And the product of roots is alpha times beta, which is c by a, which is minus 4 by 2, right? Which is minus 2. So you know the sum of roots and product of roots. Now, I'm changing color. You're seeking an equation. I'm seeking a new equation. Seeking a new equation, okay, whose roots are, I'll call them, okay, fine. Whose roots are 1 by alpha and 1 by beta, right? The roots are 1 by alpha and 1 by beta. So what is the new sum? I'll call this S dash as the new sum. The new sum is 1 by alpha plus 1 by beta. And the new product, I'll call this P dash, is 1 by alpha into 1 by beta. So the new product is nothing but 1 by alpha beta. I already knew my alpha beta is minus 2. Therefore, this is 1 by minus 2, which is minus half. So the new product is minus half. The new sum can also be figured out. This is just alpha plus beta by alpha beta, right? Or rather beta plus alpha by alpha beta. But alpha plus beta, I know from here, it's 3 by 2. So it's 3 by 2 upon minus 2, which is minus 3 by 4. So I know the new sum, I know the new product, and we have seen earlier in class today that the equation is x square minus sum of roots times x plus product of roots equal to 0. So just by substituting that, it's just, oh, sorry, I'm running out of space here. I'll just continue upstairs here. So x square minus the sum of roots was minus 3 by 4. X square minus sum of roots times x plus product of roots was minus half equal to 0. And of course, you can multiply by 4 or whatever just to make it nicer. So 4x square plus 3x minus 2 equal to 0. So without any weird square root of 41 and all that stuff, I've arrived at an equation whose roots are the reciprocals of the original equation's roots. Is this clear? Okay. All right, let's stop here for today. And then, yeah, obviously I'll assign homework from the end of chapter for quadratics. And then we'll resume in July. I think July 8th or something is what I discussed with your parents. You guys are all back from various school stuff and other activities, right? Okay, but use this time wisely, guys. This 1 month a break. You have had 6 sessions. Go through all of them from the beginning to the end, all of those video lectures, and go through all the practice problems at the end of the chapters, and make sure you're solid by the time you come back. Okay,
Yes.
cool. Chalo, I'll see you then. Bye.
Thank you, sir.
Bye.
Sir.
See you soon
Thank
in
you.
a month and a half approx.
Bye.
Okay, bye.